This lab is similar to Lab B, except that instead of putting out a square wave to turn on LEDs, our square wave will turn on a speaker. Here's part of the code that we are using. If you'll notice, we're taking the number FF in hexadecimal, going to accumulator A, and then to port 2. The effect of putting FF at port 2 means that all the pins on port 2 will go high. What does high mean? It means 5 volts. Once I take all the pins of port 2 high, I put myself in a little loop, and this little loop is called high 1, and it consists of no op and decrement and jump and not equal to 0. So the key is how long will I stay high? A little bit lower in the code, once I get out of the high loop, I'm going to do the same thing. I'll put 0, 0, go to accumulator A, and then port 2, which will take all the pins at port 2 low, and then I'm going to put myself in another loop called low 1 for the same amount of time as the high loop. But of course, we still need to calculate how much time we're talking about. Both the high loop and the low loop are the same and consist in low op with 1 machine cycle and decrement and jump if not equal to 0, 2 machine cycles for a total of 3 machine cycles. To calculate the time high or the time low, we say FF in hexadecimal times 3 machine cycles times 1.085 microseconds. In other words, 255 times 3 machine cycles times 1.805 microsecond equals 830 microseconds. 830 seconds microseconds high, 830 microseconds low. We have created a square wave of 830 microseconds high, 830 seconds microseconds low. This gives us a period of 1.66 milliseconds. To calculate the frequency, we say 1 over the time is equal to 1 over 1.66 millisecond, which equals 602 hertz. So we have created a frequency of 602 hertz. This is much higher than we did before. It's because the eye cannot see very high frequency, but the ear can hear higher frequencies. It is this square wave then that'll come out from any pin of port 2 that'll go through the 10K resistor to the base of the transistor. As the transistor goes high and low, it'll turn the speaker on and off. In other words, the speaker will move forward and reverse, and in doing so, it'll produce the sound. Here is the circuit in operation using the original code, and then if everything is working right, it should be putting out a sound, a frequency of 602 hertz. And then it'll be a challenge then to reverse the calculation to see if I can put out a frequency of 1 kilohertz. In that case, you have to simply rearrange the formula to find out how many machine cycles we need, and so change the code.